Um, First of all, thank you very much for the chance to present to you here today. I'd like to thank the organisers. The title of my presentation is the characterization of seasonal groundwater processes in an agricultural catchment using geophysical, isotopic, and hydrochemical techniques. This is from Loughgur in Midwest Ireland. I had many collaborators on this project, and I thank them all, and they're listed here above. So with this presentation, I'll just go through Loughgur itself, its significance, and some of the motivations behind the project. I'll go through the geophysical survey that we carried out, the radon survey, and some hydrographs from the catchment. Also look at some stable isotopes of water, the DXS, also some carbonate weathering data, and also we'll look at the processes and dissolved inorganic carbon. So firstly, to speak about Loughgur itself, I suppose some of the motivations really behind the project. So this lake is a shallow groundwater-fed eutrophic lake in a karst volcanic geology. And there have been some issues with algal blooms over the last in the 2010s, and there's a lot of motivation for stakeholders, the Geological Survey of Ireland, the local county council, in terms of just understanding the system better in terms of the hydrological network and also the hydrogeology of the system. So the objectives from this piece of work that I'm going to show to you today would be the seasonal dynamics of groundwater origin, flow path networks within a geologically heterogeneous groundwater-fed lake catchment. And also we'll look at some water-rock interactions and associated groundwater recharge and evolution processes through just some indicators from using stable isotopes and how useful it is. So this is just a look at the location of the catchment. It's a small catchment in Midwest Ireland, about 20 kilometres south of Limerick City. It's a popular archaeological and tourism site, so that's one of the other motivations for actually understanding the site a little better and getting some more information about the local authorities. There's about 100,000 visitors here a year. It's a beautiful site, and there's significant archaeology as well. 3 millennia of history here, going from megalithic tombs up to the present day, housing, etc. The lake itself is about 79 hectares, mean depth about 2 meters, precipitation about 1,000 millimeters per year, and mean average temperature about 10 degrees. The fact that it's so shallow also means that it is quite susceptible to eutrophication, obviously, in algal blooms, as the light penetrates the entire water column. So it's about 1.5 to 2 meters in average depth. You can see there some algal blooms from a few years back, so that's not uncommon. It's becoming more of a problem over the last few years. You can see in the catchment as well, we have a number of groundwater monitoring sites and surface water monitoring sites also. In terms of the lake itself, the history, so it was 2 meters higher up to about 1850. During the 1840, 1850, during the famine, it was lowered by 2 meters during some of the works that were carried out there. And prior to that, the only outflow from this lake was through a swallow hole. Just in the northeastern corner there, Pula Vadra it's called. I'm not going to translate that for you from the Gaelic because it's quite impolite, but it goes from that side of there's a 1,800 meter conduit flow path essentially under Grange Hill, it's called, quite an elevated area, to some discharge springs on the far side, which then feed the Ballycanaan River. Just following on from the professor there, we carried out some tracer studies also on this conduit system, not to the extent that that the professor did, but we carried out some under low flow and high flow conditions, and we're really looking at the connection. There's actually, I haven't showed it here, but there's actually a connection of springs along that northwestern side. And, you know, we wanted to essentially look at it under high flow and low flow conditions to see was there any sort of activation of conduits under different water levels. And we see that there's a perennial flow from the lake to SW2, which is called the Creamery Spring. There's an old creamery there and used to supply the water to it in summertime. And then we see a connection under high flow conditions in around February, March, where it actually discharges at SW2 and SW3 as a field spring, not too far away from it. So that was really interesting. What else can I say about that? The lake is also fed by a fen area, Lake Bog. For that's only for about 6 months of the year, but generally it's groundwater fed. And there is a surface water outflow channel there, artificial channel that was dug to lower the lake level in about 1840. And that's still active, but thankfully the swallow hole still is there. So in terms of local geology, you have Ballynash member of Ballysteen limestone formations, the oldest bedrock outcrop in this area. The majority of the local groundwater catchment is underlain by karstic Sortian limestone, with higher elevations underlaid by younger Lochgur limestone and Knockgrove volcanic formation. So this site is actually quite unique and a little bit exotic for Ireland, in that on the northeastern side, you have volcanics overlying the limestones, and the best aquifer of all those is the karstic Sortian limestone, and that's overlying this Lochgur formation. But you have a fault line there as well you can see in the catchment, and I'll talk a little bit about that in a second. Yeah, and there's quite a lot of outcropping across the catchment, really. You can see here the geological profile, and you can see to the east side, the northeast side, that's the prevailing groundwater flow direction comes from that side to sort of west-northwest. So we carried out, we were very interested in this conduit flow path after we did quite a few of these dye tracing studies, and we have we carried out a geophysical survey with 2 terrestrial ERT survey transects at T1 and T2 along that conduit flow path from Poolavadra out to the springs. They're about 480 meters long, going from southeast to northwest direction. So there's low resistivity at about 320 is likely a perched water table. You can see in this transect 2. In transect 1, you can see a low resistivity area about 160 meters away from the lake shoreline, and that continues actually more low resistivity area in transect 2. Then also kind of it aligns in some respect. Then you have this perched water table at about 320 in the T2, in the transect 2 ERT transect 2. The locations of the low resistivity areas suggest this is the location of the subsurface conduit flow path. And there's a lot of thinking about this flow path, and the likelihood is that it's along the bedding plane of the Sortian limestone and the Lochgur limestone formation. And that's what we were kind of seeing as well from our geophysical work. We were hoping to continue that a little bit further down the conduit flow path, but we had problems with livestock, and I don't know if any of you ever done ERT surveys, which you don't want livestock interfering with them. So we had some issues there, but we didn't unfortunately get a chance to do that. But there is like a very large doline just before some of these 2 outflow or discharge springs, which makes me think, did that have something to do with changing the pattern of discharge with that? But eventually we'll get to it. So both we carried out an aquatic geophysical survey also to look at some discharge locations in the lake bed of groundwater, essentially. So quite interested in that. And thankfully prior to starting the study, there was a radon survey done just previous to it, and that kind of educated us as to where would be best to put our aquatic geophysical survey. So both aquatic surveys showed the lake water depth of about 1 to 2 meters and a water resistivity of about 10 ohm meters. Sub-bottom, yeah, the sub-bottom resistivity is about 10 to 30 ohm meters with a thickness of about 10 meters of sediment. Low permeability clay and marl, possibly more localized zones you can see there. So there are areas of discharge there. So beneath the resistivity values increase, indicating karstified Sortian limestone underlying the lake. And the values here are about, just from memory, about 800 to 1,200 ohm meters, which wouldn't be untypical for this type of limestone in this part of the country. So I probably should have shown this slide before the last one, but here we have the radon survey carried out. We carried out 2 of these actually, and this is just to show where you can get discharge in a standing water body, and it was very useful. Radon 222 coupled with some electrical conductivity logging of the lake, and we identified these areas. One of the primary areas is along this fault line, going from, the prevailing groundwater flow direction was from the east, northeast, to sort of the west, north, so the west, north. But you see there along the amenity center site there, there's a significant discharge location there, and also hugging there, Knockadoon, it's called, that part of the catchment jutting into the lake there along that shoreline. There's quite a bit of groundwater discharging, and then just hugging the Grange Hill side of the loch also, there's quite a bit of groundwater discharge. So we put in place 2 shallow piezometer nests in these zones of high radon, just in the hope that we catch some of this groundwater discharging into the lake. Yeah, so that leads us on then to show, I suppose, that there's quite a lot of groundwater surface water interaction in terms of looking at the hydrographs from around the catchment. There's quite a lot of outcropping, so that's not unsurprising, but it's nice to see the proof in terms of the hydrographs. They're very responsive to precipitation events with short lag times. Piezometer nests were installed in 2 locations, as I showed there on the previous slide. We also carried out some falling head tests just to get some values and figures around hydraulic conductivity of the sediments, etc. So the hydraulic conductivity values in PZ1, which is up around the amenity center there, up in the northeastern corner, values increased going down the sediment profile, whereas in the second piezometer nest, there was a decrease in values from the upper to the middle, then they increased again. So there's overall significant surface water groundwater interaction here. Just if you take a look at the hydrograph there, that basically is a borehole. The solid line GW1 is a borehole to the east side of the lake at a slightly higher elevation, and it's pretty responsive after rainfall events. And then the GW13 is a borehole along that conduit pathway at a slightly lower elevation. And again, we see quite a response to rainfall. And then we have also the lake level there as well over a 2 or 3 year period. So in terms of stable isotopes of water, these are very useful for looking at, can look at recharge sources, pathways, and also residence times, particularly in standing waters or in groundwater. So they reveal significant groundwater surface water interaction during high flow periods. Just from the last piece of data I showed you there from the hydrograph, the O18 and deuterium signature from that GW1 is quite similar to the lake and to the outflow of the lake during high flow periods, which shows that there's quite a bit of interaction, groundwater, surface water interaction and mixing going on during high flow periods. Yeah, the O18 signatures plot above the meteoric waterline and local meteoric waterline, potentially indicating hydration of silicate minerals and a direct isotope exchange of O18 with the water and rock minerals, which is very interesting actually. That signature was a little bit unique, and it could be one of either of those. I got quite excited earlier when I saw the results from my colleague in Stantec showing the amount of sediments coming up from some of the boreholes he pumped in the west of Ireland, and in terms of hydration of silicates, with some of our results, there could be quite a lot of sediments within these conduits. So it was nice to see that. So groundwater O18 and deuterium signatures during the low flow periods indicate recharge sources are influenced by enriched surface waters, precipitation, quite a wider range of signatures. You can get these during high flow periods, indicates greater variation of sources really. So then DXS signatures illustrate the rapid rainfall infiltration under high flow conditions, demonstrating vulnerability to groundwater, while the lake water signatures confirm widespread groundwater surface water interaction again. Also, interestingly there, the hydrochemicals confirm both acyclic weathering and carbonate dissolution of primary chemical processes with magnesium and calcium ratios. So within this catchment, the geology has quite a relatively high magnesium concentration. There's quite a bit of dolomite actually in this limestone, within this limestone, these limestone formations. And that's not untypical also for this part of the the country. But it can be quite useful in terms of being used as a groundwater residence time indicator, magnesium. So yeah, during low flow periods, we see that. Yeah. So then, just to talk quickly about the carbonate weathering, which time we get? Okay, the carbonate weathering and process and dissolve DIC. So there's correlations between the C13 of DIC and DOC, gives an additional information on the source of dissolved organic carbon to the surface and groundwaters. So the signatures from the inflow, from the inlet piezometers at Lochgar under high flow conditions suggest oxidation of organic matter is the likely source of DIC. For groundwater samples, there is a slight positive correlation under high flow conditions, which is very interesting, while under low flow conditions, then there's a negative correlation. So the correlations between the DIC and dissolved organic carbon suggest a seasonal switch in the source of DIC to groundwaters between oxidation of organic matter in the summer and then sort of a dissolution of the carbonate minerals in the winter. So we also carried out some saturation indices of calcite, illustrates calcium carbonate precipitation along with CO2 evasion is a perennial process. During high flow periods, many water compartments are supersaturated with calcite and undersaturated for dolomite, which suggests that magnesium could be coming from dolomite dissolution and weathering. Under low flow conditions, the elevated source of magnesium may be due to the partial dissolution, as I was saying, of dolomite and accumulation then of this magnesium due to incongruent weathering. So here is just a conceptual model we developed of the lake. So this hydrogeological conceptual model of Lochgar catchment enables an accurate visualization of the perennial groundwater flow direction, inlet groundwater discharge locations, as well as the seasonally dynamic hydraulic processes. We also carried out some measurements for N15 of nitrogen, nitrate, but I haven't got the chance to go into it here. But we did a lot of work around this. So there's variations in the seasonal connectivity between surface water and groundwater surrounding the catchment groundwaters were highlighted by the branching out of this local evaporation line under high flow conditions. And elevated groundwater levels activate under Karst, in the upper Karst conduits in the original unsaturated zone, which results in a complex flow paths and increased water source connectivity. And we saw that in particular from our dye tracing studies, where we looked at the dye tracer under low flow and high flow conditions, and we see basically a difference, and but there is a connection there as well. So it was very useful to use that. And also in terms of using the water isotopes, we see that the DXS values are similar or the same really from the pool of homogeneous swallow hole to the outflow, and then we see a difference really then from the DXS signatures at the field spring, which shows that there's actually that field spring during summer is getting water from a different source area, basically. I'm sorry I had to go so quickly, but I'm playing to catch. But if there's any questions, please.